We talked about this. We talked about the complexity of a device like this. This is called a multifunction device. So give me a little bit. Talk to me a little bit about what is that layer 1? This is called the physical layer. What are the items that are at layer 1 when we talked about the multifunction device? Just kind of a review. Just put all of it back because I'm afraid it leaks out on the other side. And just to try to put that all back in your brain.
The device itself, like the physical aspect?
The physical outside, definitely. I mean, the connectors. We can see that we've got our WAN connector, our switch. These are very, very different items between this jack and these 4 over here. Radically different. Okay, so be aware. This, so all of our jacks are definitely there. What else is physical? Anything else physical? Obviously cable.
The internal components?
Possibly some internal capability. What about data link layer? What in our multifunction device of the functionality, firewalls, DHCP server, we've got a router here, we've got a NAT, we've got a switch, we've got access points. What else is layer 2? What is layer 2?
Radio.
Radios, yes. Our 2.5 and 5 gig radios are layer 2. What else?
Switches.
The switch, our 4-port switch. And remember we talked about there are more ports. Remember this. There are, just because we only see how many ports here. How many switch ports do we see? 4. There are more than that. They're built in, but there are more switch ports than that. And that's why I drew them here. Showing your 5 gigahertz radio, your 2.5 gigahertz radio. This is how this componentry connects to the switch. Think of the switch as the local area network. In fact, listen to me carefully. What is your local area network? It is the switch infrastructure. So if I take you in the back room and I said, what is your LAN? Your answer to me is my switch, my switches, and my cable infrastructure. That's the answer. When I say, what is a LAN? What is a local area network? It is the switches and the cable infrastructure. So when we talk about a local area network, we're talking about switches and our local area network. So for most of us at home, this is the only switch we're going to have, but I'm going to show you later on, I'm going to show you some very cool ways of daisy chaining these multifunction devices so that you can extend your network. You can put another extension of your network in a further area of your home. So there are ways that we can take this technology, leverage it, and extend our network in our home. Okay, so there's cool ways of doing that. What's at layer 3? So this is called the network layer. This is where we have packets. Notice at the data link layer we have what? We have frames. They're called frames. And then at the physical layer we call them bits. And this is very important. This is one of the definitions, the things that you've got to start learning. When I talk about the network layer, this is layer 3. And this is where the router resides. I also mentioned the other day, I talked to you, this is where layer 3 is where NAT resides. DHCP resides at the application layer, but NAT resides at layer 3. What about firewall? We talked a little bit about what layers, in this case, firewall actually covers a number of layers. Does anyone remember?
Data link all the way up. Right?
Exactly. Very good. You're looking at your notes, and that's good. From data link layer all the way to application layer, your firewall actually is a multi-layer device. Okay. So I want to go in and let's take a look. What I want to do is, now that we've refreshed this diagram, I want to go in and let's take a look at the software that controls each of those logical functions. Is that okay? So let's go do that. So watch what I'm going to do. I'm going to actually go in, I'm going to open up a browser, and it would be good if you saw what I saw. And I am going to go up to display port. In order for me to get into the router on the LAN side, and if you'll, what I'm going to do is I'm going to type in 192.168.1.1, and that is the actual IP address of the router. And let me pull that up here. I'm typing in the account to get in here. I want to go back. I want you to look at that IP address. That's very important. It's a Class C address. I'm going to go back down to the picture real quick, and I want to show you where I'm at. I am actually, you can do it. I'm actually going right here. Actually, I think what I'll do, just to clarify, I'll get rid of all of my garbage here. So here is my router. Each of these connections, I want you to look very carefully. This is going to have 192.168.1.1. That's going to be the IP address of that router. And I'm actually going to go in and open up the interface of the software to that router. So here we go. Here, and so what I've done is I've actually went to the IP address of that router, and I've pulled up the software interface. So this is a Linux, embedded Linux interface that allows me to set up those areas. So I want to focus on this. This right away, notice we're at the DHCP server. So this area right here is really focused on the DHCP server. We'll get back to that one. I want to go, this is the wireless. So this allows me to configure the 2.4, I think, let me make sure, yeah, this is the 2.4 radio, 2.4 gigahertz radio. This is the 5 gigahertz radio. So this allows me to configure those two radios. I'm going to also go to, this is, I talked about the USB device where we can actually turn our Linux router into a Windows server using Samba. So this is where I'm going to go in and set up the Windows server, and I'll have the ability to do a couple things. This is very interesting. Linux has built in not only the Windows server functionality, but a media server and an FTP server and a few other functionalities. So if you would like to use that external hard drive instead as an FTP server, or a recognized media server standard, you can actually do that both. So you can do it, you can make it a Windows server, a media server, and an FTP server. We're also going to get into, let me go back to the setup, and this is where we're going to get into, I'm looking for this area here, right here, is the area of my router that allows me to set up with my WAN provider, my ISP, Bright House, CenturyLink, AT&T. So this area is set up so that I can configure and get ready for connecting to my ISP. In most cases, notice, most vendors that bring you internet are going to allow you to use DHCP. So I'm going to pull that information from my ISP provider. It's going to set up this portion. Let me go here real quick. This is normally, this is your WAN. This is very important. This is the WAN connection. This is typically set up by your ISP via DHCP. That isn't always true with every provider, but this connection on this side of the router, which is the yellow connection, if you look at my yellow connection on this multifunction device, that is the WAN connection. And that is generally pulled the information you need on this interface. The information you need is generally brought via DHCP. So you're going to get an IP address, a subnet, you're going to get routing information, you're going to get DNS information. So your ISP is going to provide critical information to this router. Now, very important, a lot of this information is going to be passed to everybody on your local area network. The information provided by your ISP is going to be passed through and provided to everyone. So when the cat fires up the iPad and wants to go to catnip.com, he's going to have DNS servers, he's going to have the gateway, he's going to have the information he needs to do. When the termites in the attic fire up their Android phones, they're going to have all the information they need to surf the internet and resist Terminex and all your pesticide. They're going to fight back, okay? So everybody in the house that connects to your system is going to have the TCP/IP information they need. So it's very important right away. We've got to understand this is the WAN. This is the WAN. And this interface is very critical. That's the yellow connector on the multifunction device. It's going to be provided all the necessary IP information, DNS information, all the critical stuff is going to be provided by CenturyLink, Bright House, etc. Yes? So, in my interface, so this is very critical. This layer 3 device is vital. Now, let me share a couple things that you really need to know. This layer 3 device is the router, which all of you, when you gave me the name for this multifunction device, every single one of you said, it's the router. It's the layer 3 device. So it is very important. It is what we call the traffic cop. It makes a decision as to whether packets go through or not. Many packets are going to come into your router, and the router is going to say this, drop it. So the router is going to make a layer 3 decision as to whether the packet that goes to this interface should go to the WAN or not. Now, there are going to be 3 kinds of packets that are going to come to your router's interface. One is called Unicast. These are going to be packets. There's also going to be Multicast. And then there's going to be broadcast. 3 types of traffic that are going to come to this interface, and this router must decide what to do. Unicast is like a letter addressed to each of you. In other words, I've got a letter addressed to his address, to Stefan's address, to Richard's address. That is a unicast. We call that point-to-point traffic. In other words, the packet has a specific place it's going to go. Okay? Most of the traffic, I would say 85% or more of your traffic is unicast. So when you look at your local area network, when we start peeling back as we start looking at your local area traffic, most of the traffic is going to be unicast. But what if Richard wants to talk to a group of people? I want to talk to everybody that likes catnip. Okay, so all the cats in the house that fire up their iPads and they want to be part of a multicast group. That's going to be a packet that's addressed to a group. Okay, that's going to be multicast. Now, listen carefully. Your router can be configured to allow multicast to pass through. In fact, the router can participate in multicasting. So 90% of your LAN traffic is going to be unicast. Your router, which is a layer 3 device, is going to make a decision, should the traffic go to the other side? Should the traffic that's coming here come to my LAN? That's what your router is going to make a decision on. Now the last traffic, listen to me carefully, is about 5% of your traffic. All right, listen carefully. Broadcast, look at me, this is important. Broadcast is good and bad, okay? Broadcast, so I've got, let's say Richard has got his iPad on the LAN. He decides to put a broadcast packet out. What does that mean? That means that everybody in the house must stop what they're doing and look at his broadcast. That means what we call shouting out information. So if think of it as a letter. Think of Unicast as a letter addressed to Richard. It's going to go specifically to him. It's point-to-point traffic. Think of a multicast as a letter addressed to the state of Florida, a group. Okay? So it's going to go to everybody in the state of Florida. But think of a broadcast as a letter to Santa. It's going to go to the whole United States because we don't know where he is, okay? So think of a broadcast as something that goes to the United States. This is a packet that says, if you're on the LAN, stop and look at it. It may not be information you care about. You may not want to look at it, but a broadcast requires you to look at that traffic, okay? So this is why I say it's bad and good. We're going to find out that broadcast is a necessary evil, okay? Here's what I want you to understand. When your traffic, listen to me carefully, when broadcasting rises above 5%, listen carefully, your computers all slow down. Did you hear that? When your broadcasting percentage goes above 5%, every computer on your LAN is impacted. You say, well, why? Because they have to stop what they're doing. Okay, I'm playing a game. There's broadcasting coming in. That means my CPU is told, stop, look at the broadcast. Whether you like it or not. You look at the broadcast and it's some silly message from somebody else. Doesn't matter. You have to stop and look at that. So once broadcast reaches a certain percentage, it actually causes every computer on the LAN to slow down. So guess what routers do? What do you think routers do to broadcast? Remember, they're kind of like a traffic cop. If I want to send a packet to Richard, it's got to go through the router, true? It's a layer 3 device. It's going to make a decision. So it's going to make a decision and send it to it. On a multicast, it has to make a decision. Am I a member of that group? But a broadcast is very detrimental to a large group of computers. So here we go. Routers drop all broadcasts. So, and think of it, if I'm CenturyLink, do I want all the broadcasts from your LAN to come to the CenturyLink network? Do you think so? No. So one of the things that a router does is drops all broadcasting traffic. It makes a decision on Unicast, it makes a decision on Multicast, but there is no decision about broadcast. It simply says no. It can be over here on your network, okay? The cats and the dogs can broadcast all they want, but it's not going to who? The LAN. Okay? So there's a critical function that your router does, is control traffic between the WAN and the what? LAN. Yes. Remember, this is your LAN. So all of this area here, between here that everybody on your LAN, your local area network, you allow all of this to go on in your local area network, but the router is going to only allow unicast, selected multicast, but what's it going to do to broadcast? It's going to drop all broadcast at the router. So it's not going to go across in the WAN. So right there is a very important function of your layer 3 device called your router. So the router is making decisions on how to route packets. And in our software, as we go to our software,
Does it drive it both ways?
it goes both ways. That's a very good question. So it does make it good. It does drop packets both ways. So when we connect, this is this home page. Notice where I'm at.